All right, class, welcome. This is trig homework. We're going to go over 6.3. Remember all those numbers right there. And so sometimes I'll tell you which ones are odd numbers, honors problems, which one not here. But anyways, 51, 53, 55, those are honor questions right here. But take a look at your homework assignments because sometimes I do change things up every once in a while. So anyways, let's go with number 9. Number 9, it says, find the solutions from 0 to 2 pi, perfecto. And it is secant. Secant 3x is equal to -1. Okay, so let's go with it here. So what we're going to do here is secant, we don't normally like to, we don't think about secant and cosecant normally. We don't even think about cotangent. We want to convert everything into sine, cosine, and tangent sometimes, and even into sine and cosine. So what we're going to do is we're going to go like this. We're going to take this, and we're going to go like this. And we're going to flip these around. So that's my little symbol for flip around. So 1 over that guy becomes technically never one. -1 over -1 is still -1 over 1, right? And then we have this little rule that says that cosine theta is the same thing as 1 over secant theta. Right, that's the little rule we have. Boom. And I'm going to incorporate that rule right now. So that guy becomes cosine of 3x is equal to still -1. That's kind of fun. So if you have a -1 or a +1, they will not change, right? Anything else would. If you had a 1/2, it would become, or if you had a 2 up here, it would become a 1/2. So kind of just be mindful. In this case scenario, this number does not change because 1 and -1 will not change. Okay, so now we go to here. So now we're going to say, okay, when does cosine 3x equal to -1? And go to back to our unit circle. Hopefully you have it. -1 for cosine is going to occur right there. And that angle measurement is pi. So cosine of 3x. Oh, sorry. Let me do that again. Let me just go 3x, right? 3x is equal to pi. And then remember, it can go around forever, right? So we're going to say 2 pi k. So that one gives us all the answers. This is all the answers on the whole entire planet, universe, whatever you say. Okay. What we're going to do, first of all, we have to solve for x. And we're only going to go from 0 to 2 pi. So here's what we do. We divide by 3, and that's going to give us 1/3 of our angles. And that's cool. 2 pi over 3k. And so remember the number of revolutions. So think about this here. This is the number of revolutions we want. So when k is equal to 0, that's going to be 1 revolution. When k is equal to 2, that's going to be 2 revolutions. And k is equal to 1 is 2 revolutions. When k is equal to 2, that'd be 3 revolutions. So we need 0, 1, and 2 for this part right here. So let me do them over here on the next slide here. So k is equal to 0. The x value would be pi over 3 plus 0. Again, filling in all the details here. You don't need to do that much on your homework here, but you probably should do this one at least here. So what is going to be pi over 3 plus 2 pi. Oh, I forgot the 3 over here. That still would have been all 0, right? Times 1. The k's value is 1. So in this case, it's pi over 3 plus 2 pi over 3 makes 3 pi over 3, or just pi. That's another answer. Cool. Okay, and then k is equal to 2. So plugging in a 2 now into here makes pi over 3 plus 4 pi over 3 makes 5 pi over 3. And those are answers. Because if I were to use k equals 3, you can try it, but k is equal to 3, I would go beyond my 2 pi at that point. Or I would maybe hit my 2 pi, and I don't need that. So final answers. Here it is. There are 3 different answers. Pi over 3, pi, and 5 pi over 3 are the final answers. Let me check. Make sure Bob agrees with me. Okay, 0, yep, pi and 5 pi over 3. Okay, cool, let's go on. Let me just check something out real quickly here too. Okay, and the next homework question was number 25. 25. It says find the solutions from 0 to 2 pi, not including 2 pi, and find exact values. Oof, okay, exact values. Here we go. Sine of 2x. Oh, interesting. That looks like either a sum identity or a difference identity. So we'll think back to your sum and difference identity and think about whether it's sine or cosine. I'm going to flip to the front of my textbook. And so I need something like sine, cosine plus cosine sine. That's what I'm looking for. Sine, cosine, cosine, sine. Sine, cosine plus cosine sine. Yep, it's this little formula right here. It's sine of A plus B is equal to sine of A. I'm just rewriting the formula from the front cover of our textbook. All right, notice it matches up just perfectly with our angle measure. So that's our little formula. What we're going to do is we're going to incorporate it. So technically, the A is kind of like the A is our 2x, and the B is our x value. So I'm going to rewrite this using 2x as the A value, and x is the B value. So there it is. Notice I'm going backwards. The way we learned it is we learned it to go forward, right? So now we're going backwards on this here. So this would be 2x plus x equal to 1/2. So this would be sine of 3x technically equal to 1/2. And let's go with it. There it is. So we're using an identity to get it out of some product stuff that we have here to get into a single trig function. And then we know how to use multiple angles. So I'm going to go, I could probably do it right here. So let's go with, when is sine going to give me a 1/2? So technically what I'm doing is I'm asking this question, right? I'm asking this question, when is theta going to give me a 1/2? That's what I'm asking. And sine will give me 1/2 here. And let's see, we're in radian measurement. Okay. And that should give me, I think, pi over 6. And then the other one should be a 5 pi over 6. Cool. Okay, so don't forget, but I'm going to need all the answers, right? And then I'm not solving for theta, I'm solving for x. So now I have myself 3x is equal to pi over 6 plus all the revolutions I can make. Then I have another one, 3x is equal to 5 pi over 6 plus all the revolutions I can make. Okay, so here it is. The fun part begins. We have to solve it for x. So we're going to divide by 3, but dividing by 3 is the same thing as multiplying by 1/2. So I'm going to put in like multiply by 1/3 here. And this one, you could multiply by 1/3 or divide by 3, right? So dividing by 3 is the same thing as multiplying by 1/3. So the x value here is pi over 18. Wow, that's not a value we know. Okay, plus 2 pi thirds k. All right, we're going to do the same thing over here. We're going to divide by 3, which is the same thing as multiplying by 1/3, which is the same thing as dividing by 3. So this one gives me x is equal to, looks like 5 pi over 18 plus 2 pi thirds k. Perfect. Okay, so we have 2 different values here in which we're going to have to solve each of those for that value. Okay, so let's see, where we had 3 revolutions on our hands. So don't forget, we're going to use k is equal to 0. And that's easy, right? If k is equal to 0, that's just pi over 18 here. And that's just 5 pi over 18 here. Okay, the little trick I should tell you about here is when you get to k is equal to 1, you think to yourself, I still need common denominators here, right? So when I'm going to be adding these up, think to yourself, okay, I'm going to just multiply this by 6, because eventually I'll just have common denominators right away for me. If I multiply this by 6, notice what I'm going to have. I'm going to have x is equal to pi over 18 plus, now this one is going to be 12 pi over 18 just to get my common denominators. And I'm using that value for k. Oh, that's easy now. So 18 is my denominator. And pi plus 12 pi makes 13 pi. That's my other answer. Okay, same thing we're going to do here. We're going to get common denominators first before I start writing things down, or else it'll take a whole bunch longer. So I'm going to multiply this by 6, multiply this guys by 6, and notice, yes, these two terms are going to be exactly the same as we do this process here. So I got x is equal to 5 pi over 18 plus 12 pi over 18 times 1, which makes 17 pi over 18. Almost gets to pi over here. Okay, and the next one and last one here. So since there's 3 revolutions, I got my first revolution, my second revolution, my third one is down here. So let's do that. I'm just switching colors here. So this one's going to be now, it's 12 over 18 because of this part right here, right? But now my k value is 2. So instead of rewriting it all the time, that k value is 2 for me right here. If you want to do a little faster, you can just put a 24 over here, right? So I got that, which makes it into a pi over 18 plus 24 pi over 18, which makes 25 pi over 18. If you can do that in your head, that is excellent. What I'm going to do, I'm going to erase this and put it in just more visible color here. There it is, 25 pi over 18. We're going to squeeze in the rest of the answer right inside here. Okay, so I got myself, okay, and I think you guys can do this here. I don't want to put 12, then multiply by 2. I'm already going to put a 24 pi right here. So 5 pi over 18 plus 24 pi over 18 would make 29 pi over 18. Oh, and I don't know, my last answer, I would like to be kind of separate that out as color-wise here. So 29 pi over 18. I'm not going to rewrite it, but there are our answers. You want to circle them maybe? That'll be good just to circle them. So that's one answer right here. Second answer. Third. Doesn't matter what order they come in as long as you have all 6 of these answers right here. That's what it's looking for. Okay, perfect. That's 25. Moving on to 33. 33 says find all the solutions in radian measurement using exact values only. So all solutions, so write down in radian measurement and exact values. Oof, okay. So that's kind of cool, because remember, this is a little easier. We don't have to do the extra k is equal to 0, k is equals 1. We don't need to put that step in. So here's what we're doing. We're looking for cosine. Oh, wow, there's a cubed power here. Cube power of 5x. Did not do those in our notes. All right, so let's go for it here. So looking at this right here, and thinking to yourself, okay, how do we do this here? So what happens in algebra class? What happens if you were like this and you're trying to solve for x? What would you do right here? Cool, hopefully you said it right. You would just take a square root like this, boom, boom, boom. Okay, and then the question comes up by some students is, Mr. Hungio, don't you have to put a plus and minus here? And no, you don't. You only put a plus and minus if this guy was a 2 or some kind of even power. 2, 4, 6, 8. That's the only time you put plus and minus. Because it's a 3 power, it stays exactly like that. So in this case, it's going to be a it should be a cube root, sorry. Cube root. There it is. So the plus and minus only happens if you were to have a even power here. So in this case, because it is a cube root here and a cube root there, we don't put plus or minus. And the next step is all good to go. I just might have myself cosine of just 5x equals -1. So you kind of think about if this was like -8 or something like that, right? If this was -8, it would bring down to -2. That's kind of what you're looking at. But again, -1 is so funny because it's going to keep the same number. Okay, then I'm looking for this. I'm looking for when does cosine, since I have my trig function all by itself on one side, when does cosine give me a -1? And we go up to here, we got ourselves pi. That's when that happens. Okay, so then I got myself 5x is equal to pi plus all the revolutions that can happen in the whole entire planet. Okay. And all we got to do here is divide by 5, because technically we're just solving for x. So divide that by 5, divide that by 5. And we don't need to plug in x's because we are not specific to like 0 to 2 pi. We actually want all the different answers in the whole entire planet. So in this case, that right there is the final answer. You don't need to go beyond that. No plugging in k's. K's are plugged in only to get specific values. All right, and there it is. All right, number 45. All right, 45 says find all solutions from 0. Got theta on our hands. Oh, well, now we're in degree measurement. Okay. When necessary, round answers to the nearest 1/10 of a degree. So I think I'm going to use my calculator here. I'm just thinking. So if that's the case, maybe I might have to use quadratic formula here. We'll see. Okay, got that right there. And let's go for it here. So back to algebra. The question is, how would you solve this? If you're in algebra 2 class and I told you to factor this down right there, how would you factor that? So I just use my x is my sine value. Forget the fact I have 2 theta here just for a second here. And if you think about it, I don't think we can factor this down. You can kind of try a few ways, like you have to get a -1 here, right? So the only way you get a -1 is a -1 plus +1, but that's no way you can get a -4 in the middle. All right, so in that case, we're going to have to use quadratic formula here. So that means we have to use quadratic formula here. So with quadratic formula, I have myself sine of 2 theta is equal to. Now remember, quadratic formula says I'm going to take the number here, which is technically a 1. Let me put that in a different color here. So my A value is technically 1, my B value is a -4, and my C value is a -1. Okay, so quadratic formula says opposite of my B, so -B or opposite of B, plus or minus the B itself being squared, -4 times my A value times my C value, all over 2 times my A value. All right, and let's keep on going. I think we're headed the right direction. Got myself a 4 over here. And let's see, that's going to be 4 plus 16. So that's technically 20 over 2. That's nice. And 20 is technically a 4 times 5. And there's my perfect square of 2's. So plus or minus 2 gets to go out of 5 over 2. And then here's a little trick. What we do is we want to reduce, if we can, we want to reduce this number, and that number all at the same time. So we can reduce each of these by 2 right away. So I got myself closer to the answer at least. I got myself this. So that's going to be 2 plus or minus the square root of 5 over 1. Oh, nice. And then I don't even need the 1, right? So it's 2 plus or minus the square root of 5. Okay, so let's go into the next slide here. So this is my answer. And then it could be, just could be, because remember, sine has to be caught between -1 and +1. Thinking one of these is going to fail me. So let me, real quick here. Nope, not that one. Let me go here, grab my calculator. I have to use it anyways. All right, and I'm going to go with what's 2 plus the square root of 5. And good. It's 4.3. There's no way sine could be that way. So as I split this off into two different pieces, so sine of 2 theta is equal to 2 plus root 5. And sine 2 theta is equal to 2 minus root 5. This one goes away because it's not between 1 and -1. And then let's check the other one, because the other one could just be false too here. That's cool too. So square root of 5. Oh, okay, it's a negative 0.23. So yeah, that's between -1 and +1. So we're going to get some answers here. All right, and it says also that we should go to the nearest tenth. All right, so this is good. Let's try this. This would be a good way to actually see how this works here. So what I want to do is I want to figure out, this is negative. True, true. Yeah, it's negative. Man, a lot of pieces here happening here. So what I'm going to do, I'm going to make it into a positive. So I'm going to multiply this by a -1. Because I want the positive. So here's what we got to do. Let me write it in as we do it. Okay. So here's what I got. I got this. I'm going to start approximating. And what I'm going to do is I'm going to get a reference angle. So this right here changes into this. And notice we got a -2 on my hand. So kind of be mindful of. I'm going to do that. I'm going to change it to a reference angle in quadrant 1. In order to do this, I have to make this positive. Okay, so the way we do that in calculator is we're going to take our answer and we're going to multiply our answer times -1. Cool. I just want the positive of that. And then I'm going to take this sine inverse of my answer. So second, and then click on this little guy right here. And then, oh, I'm going to make sure I'm in degrees here. Let me do that first. Okay. Or else everything else gets spoiled. There it is. I got myself my reference angle is, what do you say, right on the border here. So 13.7. I'm going to go 13.7 degrees. Okay, so now what I have is I have an angle measurement. My reference angle is 13.7 degrees, but what I'm looking for is I'm looking for a negative of this right here. So the only time I can have a negative for my sine value is if they're below the x-axis. So I'm looking for an angle measurement here and here. Okay, so let's go for it here. So how do we go from reference angle to angle itself in quadrant 3? It is going to be 180 plus my reference angle. So in this case, let me go with it here. So 193.7 degrees. Cool. Okay. And then how do we go to a angle measurement from reference angle in quadrant 4? It's going to be 360 minus my reference angle. So let's do that on the calculator. So what I can do is I can just do this here again. Yeah, I could do 360. 360 minus 13.7. Okay, 346.3. 346.3 degrees. All right, the only other thing that I have is the fact that we're not solving for theta. We originally had a 2 theta here, right? So we're going to have to take half of that. So technically you could have just put in 2 theta over here. Just don't want to confuse it too much here. So let's go with it here. So technically it was 2 theta is equal to 193.7 degrees. And oh, let's go plus 360K. And 2 theta is equal to 346.3 degrees plus 360K. Man, this is a long one. Okay, divide by 2, divide by 2, divide by 2. And finally we get to theta. So theta is equal to, and I gotta check my calculator here. Let's see. 193.7 divided by 2. Okay, so I got myself now 96 point, what is it again? 6.9. 96.9 plus 180. Okay, I need degree measurements here. Yep, okay. Then this one as well, divide by 2, divide by 2, divide by 2. All right, go up to my calculator. It's 346.3 divided by 2. All right, I got myself a theta is equal to 173.2 degrees. Now, the only other thing that I could have just kind of done is not, notice we divided by 2, and that's okay. We could have just kept this answer maybe like to 3 or 4 decimal places, then after we've divided by 2, then actually make it and round it off. So we could have done that. We might be off by 1/10 of a degree here or here, okay? And that's still okay. I'm not that worried about it. I'm more interested in making sure you guys can follow the process. Okay, so we're going from 0 to 360. We have 2 revolutions on our hands. So we also have a k is equal to 0 and a k is equal to 1. That's 1 revolution. That's 2 revolutions. So this is the easy one. One answer is that. And back of the book could be 96.8, right? Or 97.0 or 96.9. You could be off by just by 1/10 of a place here. All right, so just be mindful of that. And if you're off by that much, that's okay. You're still doing good. So the answer back of the book could be 173.2, could be 173.1, or it could be 173.3, just because we were already rounding off before we did the rest of it here. Okay, so those are 2 answers. Next one would be, and we could just do this on a calculator, it'll be 96.9 plus 180. So 96.9 plus 180, 276.9, 276.9. And we got ourselves 173.2 plus 180. 353.2. 353.2. Okay, now I'm going to check with Bob. Back of the book. Let me see what we got here. And oh yeah, we're off by 1/10 over here. Should be 96.8. That's fine. That's okay. This was correct. And this one, back of the book says, Bob says 276.8, and that's fine too if you're off just by a little bit. Cool. So I got all answers. 1, 2, 3, 4. There it is.